All right, now we're actually getting into the logic of the PLC program. Now the logic is pretty much the simplest form of C, which means that all the logic is, it contains multiple lines of if, some condition, then outcome. Now the outcome can be numerous things. It could be turning an output on and off, turning a memory bit out and on and off, setting a timer, resetting something, associating a value from one thing to another, performing some math. Uh, for example, on here, let's say, okay, let's look at this line right here. This line starts with the word if. This right here is your condition. Anything between the if and the then is your condition. Now on here, there's two parts to the condition. There's this first part, and then there's second part. Okay, this is separated by these two ampersands. The two ampersands like that is a logic and, which means that in order for anything to happen on the outcome, this part has to be true and this part has to be true. Okay, now if those both are true, that makes this entire condition true, and once the entire condition is true, then whatever is in the outcome will be performed. Okay, now another thing to notice is the first part says if this fault message underscore W, which as we talked about before, the underscore W means that it's a word value. So this is saying if this fault word value is equal to 9985. The two equal signs means is equal to. So that means that this word value can be anything from 0 through whatever. It's a 32-bit, so it's million something. But if that word value happens to be 9985, it makes this part of the condition true. Okay? And then this one says not SV stop. The not is designated by the exclamation point on there. Once you see an exclamation point, it means the inverse of that SV stop. So if SV stop is false, and I mean SV stop, but once SV stop is false, it puts this condition, which is not SV stop, true. So if this fault message and this system variable is not set, so that means that when this fault message equals 9985 and this system variable SV stop is not set, then I put the value that's tied to this, which is this message cleared underscore MSG. I assign that to now this fault message word. Now you might be saying, well, what is this? Well, if you take a look, this is what we ended up talking about previously before, which was defined in our constants. Okay, so this right here was defined 25,345 based on our definitions. So when we define that, now the single equal sign, it means that it's putting this into here. So that means that when this entire condition is true, then the outcome of this line is that this constant is now going to be placed into this word value. Okay? So we have to remember that. If there's a single equal sign, it means that whatever is on the right-hand side will then be transferred over to the left-hand side. And if there's a double equal sign is pretty much only used in the condition. That means that as long as that is equal to, so it's whatever's in the left hand is equal to what is in the right-hand side. Okay? Now, we talked about the logic and. There's also a logic or. Logic or is two lines, parallel lines together. Let me see if I can find that for you. Okay, right here. Okay, so we've got these two conditions and says this system variable or this system variable. Okay, now in this part right here, you can see that these two conditions are inside these parentheses. quite honestly, on this one, it doesn't really need it just because that's the only part of the condition that's on there. So if you left the parentheses out, it would still behave the same. But when you're creating your own custom macro, or I'm sorry, customizing your PLC program, by all means, if there's two parts to the condition that need to be met, I always say put them in parentheses. Because right now you can see and take a look that the next line is the inverse of either of those. This first line says that if this is true or this is true, then it's going to do this. But then this next line says if not either of these, then perform this. So that means that in order for this to be true, one of these has to be true. But in order for this line to be, this is essentially saying the same thing as if not SV program running and not SVMDI mode. Okay, so that is exactly the same as saying not this entire thing in parentheses. All right. Now, I'm just saying that because pretty much you'll end up seeing a lot more logic down below that might have multiple different types of conditions, and you need to make sure that the appropriate condition is in the parentheses, because if not, you may end up getting lost, and there might be certain things that won't be turning on because it's either missing or has an extra parentheses that shouldn't be there, and which makes that condition no longer true when it really should be true. Alright, so then we go into, okay, let's see. So we have that. Alright. So now, you'll see the majority of stuff, you're going to be using set and reset. The set basically is turning something on. Now, the set can turn either an output, a memory bit, or a timer. Alright, right now, because this one says, if 1 equals 1, which of course that is always equal true, then set true. But now we don't know what true is. Alright, so in order to figure that out, you pretty much have to find it and probably search, but I can guarantee you right now that true is a memory bit, which, lo and behold, here we go, we define it as mem81. Alright, and this is why I was saying it makes it a lot easier when with the underscore M, that once this thing is set true, if it was true underscore M, whoever is reading this would automatically see the true and know, ah, okay, that is a memory bit. Okay? So, what this is saying is if 1 equals 1, which of course 1 is always equal to 1, that's true, then it will perform all these conditions. Now, of course, you can see here, you can have multiple conditions, and each condition is separated by a comma. Okay? If you don't have a comma in the right place because, for example, let's say like you forgot to put a comma on this last one. Okay? If you had this and you go to compile, it will not compile. It will fault out because the compiler is going through, reading through every single line, and then when it gets to this one, it sees this as the last line of this outcome, but then it sees this, and it doesn't know what it's supposed to do this, because the last thing on, like the last condition or the last outcome that's being utilized has to no longer have a comma, but the second to the last and every anything before it has to be separated by that comma. And so once it sees that, it gets to the line, and the compiler sees, okay, this is my last line of this command, but it gets to this point and it says, I don't know what to do. Reset initialize stage. There's no if term in there, so it won't compile and it'll fail on you. So you need to make sure that if you're having multiple things, that each one is separated by a comma. And if you put, let's say you accidentally put a comma on there, the PLC program, whenever it goes to compile, it will also fail on you because it's looking for the last item and it's seeing that there's nothing on there. So it'll keep going down, and it'll see this and say, I don't see that as a set. I don't see a reset. I don't see anything in front of it. I don't know what to do with that. Okay. Okay, so we got the set, reset. Once again, here is where you have the equal sign, so you're putting whatever's on the right-hand side, it's setting it to the left-hand side, and that's pretty much it on that. All right, and as we continue down, keep looking at the PLC program, you'll see that various things might end up doing math. Like, for example, this one right here says if true. Now, of course, we just saw before that the true was a memory bit. So that means that if true, which is that memory bit, if that's being set, then we perform these three tasks. Okay. The first task is taking the system variable parameter, this whatever value is in that parameter 179, and it's loading that into this word value, this lube underscore W. And then the next part of those outcomes is it's performing some math. First part is it's going to take this number and divide by 100 and then multiply that by 60,000. Okay, this loop timer is basically part of the logic that allows the CNC control to handle or to regulate your loop pump. Some loop pumps have it where they have a timer built into the pump, and if that's the case, then that means that the Centroid control isn't doing anything with the timer, and that parameter 179 would be set to a 0. So that means that the timer is solely handled by the loop pump. But if the Centroid control had the timer or was controlling that lube output, then that parameter would be set in such a way to know how often it needs to turn that output on. By default, the parameters are set to 3015. That means that for every 30 minutes that a program is running, that output will turn on or will be on for 15 seconds. And that's what these word values are doing. It's trying to take that one number, that 3015, and break it up into how long, or break it up into two values. The one value to see how long that the program needs to be running for, and the second value is how long the output needs to be turned on for. And that's what this logic is for. Okay. Okay, now we're also looking at here this line of logic. This line of logic is looking at the value of parameter 218. That parameter is pretty much telling the control which MPG the operator is using. Either the wireless MPG, which is something that Centroid recently started supporting and using, or the original wired MPG. So it looks at that parameter, and if it's set to a 0, it's not performing the stage, or it's not turning on that stage that's for the wireless MPG, but it's setting the normal MPG stage on. And if it's greater than 0, which means that you have a wireless MPG, then it's setting that wireless MPG stage and not turning the normal MPG stage on. Now, that parameter is actually a bit-based parameter, where each bit tells the control how many axes you're turning the thing on. Now, I don't know if anyone knows about bit mapping, but let's bring up Paint here, and I'll go over how bit works. All right. For argument's sake, let's just say go with easy numbers. Let's just say that the parameter is an 8-bit number. That means that you've got bits 0 through 7 as part of that parameter. Now, I'm gonna start bringing up basic math. All right. Each bit, there's a 2's complement, because basically that bit can either be a 0 or a 1. 0 means off, 1 means on or set. Okay. And if you have, let's say, bit 0 turn on, the BCD, or the actual value that's equated to that, is essentially 2 to the 0 power, which 2 to the 0 has a value of 1. If bit 1 was set, that means 2 to the 1 power, and that has a value of 2. If bit 2 was set, that would be 2 squared, or 2 to the power of 2, which has a value of 4, and so on. So this shows basically which bits are set and the value that's associated with it. Let's say that I've got a standard mill, which is a 3-axis mill, and I want to use all 3 axes on the MPG. So that means that I'm going to set 3 bits. So I'm going to set bit 0, bit 1, and bit 2. Okay, so now with those three being set, then that means, all right, what value do I need to set parameter 218 to tell the control that I'm using 3 axes? So that's when we come in and do a little bit of math. So we're saying 2 to the 0 plus 2 to the 1 plus 2 to the 2 power. That value, add all that, that's what tells you what value needs to go into that parameter. So it would be 1 plus 2 plus 4, which is 7. So whenever the control, or whenever that software has parameter 218 set to a 7, it's telling the control that I have 3 axes that are being enabled. And if I had more axes, then all you have to do is just add the values to that. So let's say I have a 4-axis, because on the wireless MPG, you've got up to 4-axis selection on your axis selector knob. So if you had all 4, what you would do is now add an 8 to it. So that 7 plus 8 is set to a 15. Okay? And that's essentially how bit-based parameters end up working. You'll see various different parameters out there, or logic, depending on what you're going to end up using. Bit-based might end up helping out. Now, another thing that could also be done was, rather than doing bits, have the PLC program that just says, okay, whatever value is stored in 218, that's how many axes I have. For example, if I had the value set to 2, it just means I have 2 axes. If I have the value set to 4, it means I would have to set all 4 axes. And that can also be done. It's just whatever logic would have to coincide in your PLC program for that. All right. So, going over that, basically all the other stuff, same exact thing. For example, this if true, then, this is a good one. If true, then this SV enable IO override. This is a system variable that is being set. As you can see, there's coils on this, and these coils are on the outcome side of the statement rather than on the condition. Whenever you have coils on the outside of your statement, that means that whatever state your condition is in, that means that your outcome will also be in that state. So that means that if your condition is true, this output will be set. If your condition is false, this output will not be set. Okay? Now, where this is going to be very, very critical is that if you ever plan on using these parentheses, which is what we call coils, in a condition, you better make sure that this statement is the only thing that will turn on that outcome. Because if you have some other logic somewhere else in the PLC program also turning it on or turning it off, now you have competing logic, because you have this condition and you have other conditions. But if you had, let's say, if true, then set SV enable IO, and then you had another condition that said if not true, then not set, or reset SV enable IO override. But then you can have another condition that might also reset it. That will work perfectly fine. But if you've got it in coils and then you've got other logic somewhere else in the PLC program, that will compete, and chances are you'll either A, never get that thing to turn on, or what you'll end up seeing is that output or that outcome will start flashing on you. Because once it gets to this section of the PLC program, because as I said before, it goes through every single line. So once it gets to this, it looks at this condition, says, yep, that's true. Then it goes down, keeps going down the line to the other line of logic that's turning it off or doing something else, and it will do whatever it needs to because that condition is also true. So you'll get it to where this might come on for a short period of time, or it'll just be on there flashing, and it'll turn on and off, on and off, on and off, on and off. Okay? And that's pretty much the basics of the actual coding wise. I know there's been things about possibly using if then else. As of right now, that isn't in there. This is a simplistic form of C code. So it means if condition, then outcome. And if you wanted the else, then you just add another line that says, if not condition, then that particular outcome.